here, what I maybe because okay. Once we design all this, then your final summary report should to summarize the material takeout, right? I keep and to try to recall you here. Every output should be pulled out from show table here, and here miscellaneous data. If I material list, right? I check it and open it and give all the material here table. But I'm gonna copy. Let me see how to interpret this. So here, so right here. So column, I have this tonnage, beam, 3000. The concrete beam is, I'm gonna separate the bracing here. This wall and floor. So at this point, your current model sum this plus this plus this. Wow, this is kips, right? This one divided by 2 is ton, right? So what we do is, remember that, no matter what you do, we order the material based upon the steel tonnage. For the steel, we use a ton as a reference material procurement. We give them, okay, total steel tonnage is about 4430 ton, right? We don't specify much, but at least this gives us a general idea how much the steel quantity we have to order. So we're using tons, right? Steel divided by 2 tons, right? The contractor or steel fabricator, steel guys, suppliers, usually they using this reference tonnage and they factor in all labor, manufacturing, fabrication costs, and shipping. Erecting is different pool. So, but anyway, just I want you to propose. You have to summarize it. Total your building design, end up with material takeoff. First one is steel total tonnage, right? The second one is wall because it's concrete. We know we don't use a ton. Just instead we're using volume, concrete cubic yard, right? How to calculate it? Yes, easy. So I'm just adding for now this all concrete weight, right here. Wall. Floor I separated. So this is wall kips. The weight. What did I write? 2. 1, 2, 3, 4. What is this? What? What did I do? It's the open. Oh. What? Undo. What's going on? My Excel is up. Undo. Oh, okay. Maybe. Okay, I'll do it again. Oh, come on. So wall plus wall and plus beam, right? But this one is kips. So multiply by 1,000 megapounds. I'm gonna using 150 pound per cubic feet. So this one divide by this. I'm gonna get the cubic foot, right? And then the cubic yard divide by 27, 333. So this is a cubic yard, right? So I think what you summarize is both steel tonnage and concrete volume. I think in also structurally we sometimes for our reference we kind of differentiate the tonnage each column divided by our reference total floor area, right? And or let's say each one beam, yeah, this floor beam divided by your total floor area give us the general pound per square foot, right? Typically beam framing is less than 10 psi. It's Do you understand that? Because this is the total tonnage, but give us some structural engineer, we usually have some index using uniform steel tonnage. In order to do that, whatever just total number divided by your reference total floor areas, right? Give us the pound per square foot. So that is something general. Our index we use it that our current system is over design or optimal design or reasonable design, something like that. If this is more heavy, then maybe we may have a long span. So something kind of engineer we use the reference the unit square footage. But again, for your report, look at that old sample in the canvas. You may find out how do they structure. It depends on the team, but I want you to at least aware of it because you need that. In construction industry, yeah, you want to prepare the bidding package. Then you need to make sure that what is the steel tonnage, right? Your bid package, you need to specify what exactly the steel tonnage and concrete volume so that bidder should use right number. Otherwise, all day, I think you guys actually running the taking any class, right? Estimation class. You calculate the material takeoff by hand manually. It's ridiculous. I mean, that's to me is 30 years old practice. You don't have to do. To me, good to you should know it, right? It's simple calculation, right? You should know it, but how to do it, you don't. Yeah, I don't want. Yes, you don't have to use your own hand calculation. Typically, software, ETABS and Revit, if you model correctly, give us more precise steel or material takeoff. Old days, my generation, no 3D model. They using 3D drawing, structural drawing, right? They look at it, measure it, and their beam weight and length and number of beam they calculate and come up with estimation steel tonnage for each group, right? And they come up with their estimation. But many cases they miscalculate total tonnage. Some teams overestimate, some team underestimate total bid package number. Bid number is off a lot, right? Owner cannot helps the good apple to apple comparison. So to me, that's why big job typically, right? Stadium, soccer stadium, right? Type of stuff, design build practice. The owner require all design team use Revit or something like that. So they have to put together all the package with a very kind of good reasonable the cross the material takeoff so that contractor who participate in bidding don't jeopardize or calculate the tonnage so that at least owner can really see that apple to apple comparison, right? But all days, yes, if they screw up this, somebody overestimated 50,000 or 50, 100 ton, I mean, their price is going to be much higher than real, right? So I think this is the one typical example then why we need to use technologies tool. But again, I don't want your generation to do the hand calculation, right? This is at least you know that your ETAPS model is a 3D model. All the members is there. You don't have to do by hand calculation. This is something general ballpark number. Obviously, this is not the number still supplier going to use it. They have to consider probably 10% and 15% more because they know that beam they procure is 30 feet, but they need to cut it, right? It depends on their length. Some of them is lost, right? Obviously, they consider 10 to 15, some 10%, 15% more for their estimation. As there is always loss because they need to cut it out, right? Okay, so far I cover okay here. If you but I think this is enough. You could summarize it, but some teams don't add it not necessary information because here is also give you the each member, right? Pieces, number of pieces, lengths, and you don't need this. This is kind of just kind of the list the ETABS provide, but you don't need this. I think what you need is overall still tonnage, total sum, right? But your model should have all the members. If you didn't include only some miscellaneous beam, it's okay, but you don't have to add only miscellaneous beam. That's something you can add later based upon a couple of percentage later. But in generally here in this model has all the column beam, brace frame, right? Filler beam, golder, right? And your number is very close to what real. Probably I will increase maybe 3 to 5% later if I think didn't include some miscellaneous beam, right? Yeah, obviously we need a miscellaneous beam here, especially here. Here, all this parameter. This one is okay because this color is braced by this beam. But this beam doesn't have a bracing point, right? So typically, this type of beam we having two small beams like this. But you don't those beams you don't have to model here. Yeah, that's the secondary, just kind of secondary the beam for bracing purpose for torsional. Because the cotton wall is gonna be sit on that parameter beams we call spandrel beam. So those are all outside spandrel beams doing something double duty, supporting the floor and also cotton wall, right? So there's more restriction on these parameter beams. The deflection standpoint, I didn't talk about it, but usually they are more restrictive for the deflection because of cotton wall related the restriction. Okay, let me just